All right. So there you have it. It says an old Magi, or is it Magi? Magi Cube camera flash bulb, 1960s. Okay, 1960 there was a camera. I was there, sha. We used to use Magi camera, and it said used magnesium metal sealed in bulb with oxygen. Calculate Gibbs free energy delta G for each reaction. I told you in the former class that Gibbs free energy is a more convenient way to calculate spontaneity, because it includes both enthalpy and entropy together with temperature. So whenever Gibbs free energy, or you're not giving values for Gibbs free energy of the elements in the compound, you can use this formula, which is D delta G. Gibbs free energy is equals to enthalpy minus temperature times change in entropy. So once I have this formula, so as I'm giving this now, what I need to do is to balance the equation. I'm balancing this equation simply means that this will be mg plus O2 all into mgo. Now I ask myself, how many mg do I have on the left hand side? 1. Right hand side 1. How many oxygens do I have on the right hand side? 1. Left hand side 2. So I'm ignoring this half. I'm not using this method. So since I have 2 here, let me put 2 here so that it becomes 2 oxygen. Now the minute I put 2 on this compound, notice that this magnesium is now 2. I put the 2 here, so it's balanced. 2 magnesium, 2 oxygen, 2 magnesium, 2 oxygen, so it's balanced. So once I have it balanced, I will use the values I have. Now they gave me that entropy values is 32.7, 205.0, then 286. Now they did not give me any value for enthalpy. They gave me these values for entropy. So you see that entropy of a pure element can never be 0, but they did not give me for enthalpy, which means that this is 0 because enthalpy of pure elements is 0. So then the compound is MgO, so it's giving me this. So making use of what I have now, I will now have that change in entropy is the same thing as sum of entropy of products, because entropy is a state function. So it means final minus initial, so minus sum of entropy of reactants. Remember I told you that anytime you see this delta, it means that it's a state function. So minus entropy of product. Now let's put what we have on the product. On the product part, I have 26.9, and notice that when we balance the reaction, it's carrying 2, so the compound is 2 mgO, so that means 2 times 26.9 joule per mole Kelvin minus, on the reactant part, the entropy first is 32.7, but notice that this balancing it, we have the magnesium now is carrying 2, so 2 plus oxygen balanced is just one of it that is here, that is the mole. So balancing it, we now have that this is the same thing as saying plus 205.0. So when you do the calculation, if you do the punching very well, you will have that on this side, you have that this is going to be 53.8 when you punch it minus 65.4 plus 205. So this is going to give me 53.8 minus, when you sum this up, you get 270.4, right? Yeah, right. So when you get that 274.4, if you subtract, you now have minus negative entropy, minus 216.6. So negative 216.6. So it's decreasing entropy. The That's what I have. Now let me find for enthalpy. For enthalpy, which is delta H, that is heat of formation. I'm given that this is the same as a state function. So it means sum of enthalpy in the products final minus initial. That is what state function is. Then enthalpy of reactants. So if I know this, this is going to be giving me, notice that the product part I have, on the product part I have 601.2 kilojoule per mole, while on the reactant part I have 00. And notice that when we balance this, magnesium is already having 2. So that means that it will be, for the product part, it will be 2 times 601.2 minus 0 plus 0. In fact, making it to correspond, 2 into 0. So this is what we have. So 2 magnesium, and magnesium is a pure element. Enthalpy of pure element is 0. Then oxygen has just one stoichiometric coefficient, 0. So when you add it up, everything here is still 0 minus. Then when you times this, 2 times 600 and negative, negative 601. 2 times negative 601. So it will give me a positive value of 1202.4 minus 0. So it still gives me 1202.4. So this is what I have. Now the Gibbs free energy using this formula, which is delta G equals to enthalpy minus temperature times change in entropy. So making use of that formula, we now have that delta G will be equals to delta H minus TdS. And now the temperature, we always make use of this entropy, unless stated otherwise, is 25 degrees Celsius, which is the same as 25 plus 273, which will give you 298. You put 20 here, 80, 90, 593 plus 598, 298 degree Kelvin. So once you know this, let's substitute the value of our enthalpy. Our enthalpy value is 1202.4 minus our entropy value is minus 216.6. Notice minus minus becomes plus. So 1202.4 then plus 216.6. But notice that anytime you are trying to convert this, notice that, okay, sorry, before I convert, notice that I have to times this my entropy with the Kelvin, which is 298, so everything here gives me that's times minus, sorry, let's still leave it at minus. So if I multiply, everything here should give me 80,525.4 and is in joule per Kelvin minus 1202.4. So we need to convert this to kilojoule because this enthalpy is in kilojoule. Enthalpy is in kilojoule. Is heat, is energy, is in kilojoule. Why entropy is always in joule. From the question, is always in joule per mole Kelvin. So if you know that, you need to convert joule to kilojoule, and to convert joule to kilojoule, we divide by 1000. And when we divide by 1000, we get that the value get that the value will now be uh, the value will now be 80.5254. So that's our value, so in kilojoule. So once we get this, we divide by 1000 to get it in kilojoule, joule to kilojoule. Now we remember that our delta G has the enthalpy to be 1, and notice that this is minus, and when it times this one, when this times this, it's still going to give us minus value. So let's not confuse it. So let's continue where we are now. So that means that this value is minus 80.5254. So our enthalpy value is 1202.4, then minus 80.5254. So when you do the add up, notice that I'm still carrying my decimal points. Reason is because the more decimal points you have, the more accurate your answer will be. Minus minus will change to plus. That's why I'm carrying the decimal. In fact, I normally tell my students, do not approximate until you get your final answer. And my final answer is 1282.9254. So it's at this point I can approximate this to 1282.9, and this is Gibbs free energy, which is kilojoule per mole. So that is my final answer for question 1. So for question 2, question 2 says, should you invest in an engine that is said to burn air at room temperature when you were told